Problem set 79, metric volume, and then 45, 45, 90 ideal triangles. We're not doing metric volume. It involves these massive unit multipliers. I'm not doing them. You can save it for physics class or chemistry class. I'm just going to focus on this here. We haven't done these all year. This is what we're doing. As a matter of review, if you get a problem like this and they say to use the ideal 30, 60, 90 triangle, then you should have in your head the ideal 30, 60, 90 triangle. And I ask you guys if you can count to 3. If you can count to 3, then you can memorize the ideal 30, 60, 90 triangle. Look, 1, 2, radical 3. 1 is the shortest one of these lengths. 2 is the longest one of these lengths. And radical 3 is the middle one of these lengths. Radical 3 is about 1.3 something, blah, 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 okay? 1.3 is somewhere in between 1 and 2. So the ideal 30, 60, 90, 1 is opposite of the smallest angle. There it is. 2, being the biggest side, is opposite of the biggest angle, 90. There it is. And radical 3, being the middle side, is opposite of the middle angle, 60, because 60 is somewhere in between 30 and 90. So there it is, radical 3. And when you're given a problem like this, and they say use the ideal 30, 60, 90, you just draw the ideal 30, 60, 90, fire the cannons, cross multiply and solve. Or you can use scale factor. Same thing here, except for now, it's not the ideal 30, 60, 90, it's the ideal 45, 45, 90. It's even simpler. You don't have to count to 3. You have to count to 2. It's 1, 1, radical 2. So opposite of each 45 are these 1 units. And then if you say you didn't know that, if you did the Pythagorean theorem for the third side, you'd get the square root of 2. So that's what we do. It's 1, 1, radical 2. Radical 2 is more than 1, so it's somewhere, it's opposite of the 90, the biggest angle. And since 45 and 45 are equal, then the sides opposite of them must be equal. So if they give you a problem like this on page, I don't know, here, this one, and you get 3, y, and z. They say, okay, solve that with the ideal 45, 45, 90 triangle. You draw it next to it, and then you solve by firing the cannons. Let's fire this 45. This 45, we always go left to right. 1 over this 45, 3, equals, now what if we fire the 90? Radical 2 and z. That'll work. But if we fired this 45, we would get 1 and y, right? And, well, I guess it doesn't matter which one we use because we used the 2 numbers to start. So let's use the 90s. Radical 2 over z, right? Because we're going opposite of the 90s. Cross multiply, so z equals 3 radical 2. Now, here's a little trick. To do this, once you know this one of these 2 sides, you're set. Because opposite of this 45 is 3. So opposite of this 45 must also be 3. Because since they're equal angles, then the sides opposite of them must be equal. Then technically you could use the Pythagorean theorem. And when you use the Pythagorean theorem, you'll get 3 squared plus 3 squared, which is 18. Square root of 18 is z, 3 radical 2, which you can figure out. But anyway, so that is problem set 79.